Good morning, guys of grade 8. Today, inshallah, we're gonna start in section 2. Okay, last time we already done was section 1 about the rock cycle, and we said that there are main classes of the rocks, okay, which are sedimentary rock, igneous rock, and metamorphic rock. And we said any rock is already rising from an old rock within a continuous cycle, or which we known as rock cycle. And we said it depends on the conditions which the rock will be in that will cause it to change to another rock. That means we said igneous rock or metamorphic rock if they exposed to weathering, erosion, and deposition, so they could form sedimentary rock. And also sedimentary rock and metamorphic rock, once they exposed to enough heat, they could melt and form magma that will be igneous rock later. And igneous rock and sedimentary rock, if they are exposed to heat and pressure, they could metamorphose and change into metamorphic rock, and so on, guys. So that's what we know as a rock cycle. Today, inshallah, we're gonna pause or we're gonna talk about igneous rock as a one specific type or one specific class of the rocks. So here we start by a very important question. Do you think rocks that cooled and solidified from lava on the Earth's surface will be different from that cooled and solidified from magma inside the Earth? That means if we have the same magma and some of these magmas already cooled down and solidified under the Earth's surface, while the others they passed out through volcanic vents in form of lava and cooled down on the surface. What do you think? They are gonna be same igneous rock or they are gonna be different igneous rock? So that's a very important question. So regarding to what we studied last time, we know that even igneous rock or each class of the three classes of the rocks, it's already could divided into different rocks inside. So that means not all igneous rock are the same, although all of them they are produced from magma, but they still different. Different depends on two factors: the composition and texture. So that means different magma have different composition based on what kind of rocks are molten in that magma and what are the minerals that are contributed in the making of this magma. So that will create different igneous rock. They are different in their structure. And also if the magma is the same, like the example which or the question which we ask here, if it's still the same magma but some of it cool down under the surface and the other already cool down above the surface of the earth, so of course they are going to be different, because once it cool down under the earth surface, it means it will cool down in higher temperature compared to the temperature in the or on the surface of the earth. So like this, that means underground magma will cool gradually, taking long time, which is gonna make it have a larger grains, and in that case, it will have a kind of rough or coarse texture. While once magma cool down on the surface, it won't cool down suddenly because due to the very low temperature compared to the temperature of the magma, and in that case the grains of the rock will be too small and the texture of the rock will be smooth or fine. So it means in that case we are going to have two types of igneous rock, although they have the same structure but they have different texture, depends on the time needed to cool down. So here that's give us a hint about how we could classify the igneous rock, or how what are the different types of igneous rock. So let's start our lesson. To know by the end of our lesson, we should be able to describe the three ways that the igneous rock forms and explain how cooling rate of magma affect the texture of igneous rock, and distinguish between igneous rock that cools within the Earth's crust and the igneous rock that cools at the Earth's surface. So let's start by the first. What is the origin of any igneous rock? As we know, any igneous rock is already formed from magma. Once magma cooled down and solidified, gonna form igneous rock. The question is now, what could form a magma, or how magma could form? So all of us, once ask this question, you're gonna just have one idea in your mind, or just you're gonna have one answer. Simply, when rocks are heated too much, or they already heated by enough heat energy, they will melt. Yes, that good answer. That's one of or the most common way, okay, and the well-known way of formation of magma. That means when rock is heated, okay, it will make the rock melt, and in that case, we form magma. But we still have other two ways that could form magma. The second way is when pressure is released. What what the rule of pressure in that case? Actually, let's get an example to clarify the idea for you. You studied in grade 4 the difference between gases, liquids, and solid. So we said gas, the particles are they are far apart from each other, or there is a large distance between particles, and particles move freely. But in liquids, the distance between particles is somehow is medium. Okay, that means not that big distance and not that small, and particles also move freely. But in case of solids, particles are tightly packed to each other. That means the distance between particles are too small, and just particles just vibrate. So in that case, if we keep pressing on a gas, pressing that means applying force on the gas, that will make the particles become closer to each other. That will, at certain distance, that means the gas will turn to be a liquid. Okay, that the same like the different aerosols or different compacted gases that you use in your home, like for example the Axe and other sprays that you have in your home. Once you shake the can, you find the can, you find it's already contain liquid, but actually when you just press on the bottom, it releases gas. So simply because under inside the bottle the gas and under pressure, so it turned to be a liquid. But once you click on the bottom, you release this pressure, so the liquid return one more time into gas. So even if you keep pressing, as we said, if you press on the gas, it will turn to liquid, and if you keep pressure, it may turn to the solid. So that's here also. If we move in reversed way, we could have a magma. What does it mean? For example, if we have some hot rocks, they are hot, not molten, they just hot. That means the temperature is not enough to melt them, but just hot rocks. If this hot rocks is already which found under pressure, if this pressure is released for by any ways, for example make some movements of the earth's tectonics like uplifts, or sometimes because of removing of some layers of rocks, or whatever the reason, okay, that the pressure decreased, in that case the particles which are hot will have more chance to move further apart from each other, so they turn from solid state into liquid state, and in that case we're going to have a magma. So that's how releasing pressure could form a magma. The third way in which magma could be formed, which is the change in composition. What mean by the rock changes, how that composition could change? As we know that rock is a mixture of different minerals, and minerals are made of different elements. And as we know that different minerals, okay, and different elements, they don't have the same melting point. That means not all minerals they could melt at the same point. So sometimes the composition of rock is made of some minerals which are have highly melting point. That means they could not melt easily. They require a very high temperature to melt. But once the composition changes due to some chemical reactions that happen under the ground, and the one mineral replaced another, or that mean the chemical composition of rock somehow changed, this new combination of minerals in the rock, okay, may have lower melting point, so they could melt easily even, okay, in the normal temperature. That means, for example, if we have a rock that's made of minerals X, Y, and Z. So these three minerals are hard and they have high melting point, so they could melt about 2000 degrees Celsius. So if just the temperature under the ground, just 1000 degrees Celsius is not enough to melt them. But if the kind of chemical change that's happened in a state of structure X, Y, Z, there is an element W replaced Z, so it become X, Y, and W. So X, Y, and W make the new combination of minerals have lower melting points, so they could melt at 700 degrees Celsius in a state of 2000. So in that way they will melt easily, and in that case magma will be formed. So like this, magma will be formed by three different ways. And the first, once magma is formed, it's easier to cool down later and form igneous rock. So here we said that different igneous rock, they have different, okay, characteristics based on their structure or composition and the texture. So let's find some differences between their igneous rock properties. Okay, so first one here, regarding to the composition, what are the minerals involved in the structure of the igneous rock? We're gonna find that different igneous rock have different characteristics or different properties. One of the most important characteristics of igneous rock are the color. So we could classify igneous rock based on their color into two major categories. First one, okay, we call them the felsic igneous rock. What are felsic igneous rock? They are igneous rock which have bright or light colors. Okay, what makes some igneous rock to appear colorful, or sorry, to appear light or bright like that? It depends on what are the elements involved in their mineral structure. Okay, so if the rock is rich in sodium, potassium, aluminum, silicon, these elements will cause the rock to be appear in bright color. But if we find that the rock is rich in another elements like iron, magnesium, and calcium, that case will cause the rock to have a dark color, and in that case we describe it as mafic rock. So here like this, we have felsic igneous rock and mafic igneous rock based on the color. The other thing that we could classify rocks depends on, okay, is that texture. Okay, what mean by texture? That mean the touch, okay, the size and the shape of the particles of the rock. Is it that rock smooth or rough? So that depends on the time needed to cool down or to magma to cool down. So we could observe easily that rocks once they already cool down faster. That means once magma find its way outside to the Earth's surface through volcanic vents and turn to lava, lava could cool down due to the huge difference in temperature between the atmosphere in the on the Earth's surface and the magma. So it will cool down suddenly or quickly, and in that case, okay, it doesn't have enough time to build the large grains. The grains will be too small, and in that case, the texture of the rock will be fine or smooth texture. But in the other hand, if magma cool down gradually under the Earth's surface, okay, so that means it take enough time to build large grains, and in that case, the texture of the rock will be rough or it will be coarse texture. So it means we have two types of rocks depend or two types of igneous rocks depend on the position in where the magma will cool down. Magma could may cool down under the ground or may cool down above the Earth's surface. If magma cool down under the Earth's crust, in that case we call it intrusive igneous rock. If it cools down above the surface, we call it extrusive igneous rock. So what difference between intrusive and extrusive igneous rock? That which we're gonna know next session, inshallah. Please study this part well from your textbook, and if you have any question, you can contact me anytime. Thank you and goodbye.